All right, an explicit formula for a sequence is a general term of a sequence, and it's written in terms of its position, that n number, instead of being written in terms of the previous one as it was for a recursive formula. So for example, if we have a sequence that says 2, 4, 6, 8, 10, and so on and so forth, then we can look at this and say, well, this is position 1, and this is position 2, and this is position 3. So is there something that we can do with these numbers to get what the terms of our sequence are? Well, if we multiply 2 times 1, we get 2, and 2 times 2, we get 4, and 2 times 3, we get 6, and 2 times 4 is 8, 2 times 5 is 9, or is 10, so we need to look, and we say, well, we can write it as 2 times the position. So our general term, which is the explicit formula for this sequence, would be 2 times m. Now those 5 different types we've talked about before, the arithmetic, the geometric, the Fibonacci, the factorial, and the harmonic, we looked at in a previous lecture their recursive formulas for each of these and talked about what that meant. And we can also do explicit formulas for these. We said an arithmetic was when we had a common difference. We were adding terms between each one. And so its explicit, or its general term, is when we start with the first term, whatever that happens to be, plus, and then whatever our n is, minus 1, times d. So for this one here, we added 2 between each term. This is an arithmetic sequence, so we could write this as an equals the first term plus n minus 1 times the common difference. And then you'll notice that if you distribute, you get exactly what we said it was going to be. So this formula works for an arithmetic sequence. When you know the first term and the common difference, then you can have an explicit formula for its for the sequence. So geometric is a similar thing. We can take it, and we said we were multiplying times our common ratio r every time. So basically what that means is we start out at the first one and we multiply times our common ratio r, whatever, one less time than what our position is. So that'll get us up to the position we want to be. So that's this general formula. Now the Fibonacci explicit formula is almost never used. I'll tell you that right now. It's pretty much always listed as recursive because, as you can see, this is not necessarily the prettiest equation. It takes a little bit of work and it's not easy. So Fibonacci, you need to be able to recognize that, but it's almost never used. Factorial is actually very easy. We start with the position and then we take its factorial, and hopefully by now you realize from the probability and things like that we've talked about that factorial means you start at that number and multiply it times everything below it. So like 3 factorial would be 3 times 2 times 1, or 5 factorial would be 5 times 4 times 3 times 2 times 1. And you just keep going down to 1. Remember, factorial, you're multiplying the position times the number before it. So if every time we start at 1 and every time we get to the next one, we're multiplying the position times the number before it, we end up multiplying all those different positions together. Excuse me. Now, harmonic is very similar to the arithmetic because, of course, it's reciprocal. So we're going to take 1 over the first term plus n minus 1 times d. So remember, we're just adding stuff to the bottom of each term, and that's how we get the harmonic. Again, the arithmetic and the geometric are the most important. You need to have those memorized. Now let's look at a harmonic sequence here. Now, the way we can tell that this is a harmonic sequence is because we see that it's adding something to the bottom of a fraction. So that means it's harmonic sequence. So if I want to know a formula for the general term of this, then I'm going to take my formula and I'm going to plug numbers in here. So first I have to figure out what D is. And so D is what we're adding along the bottom. So we're adding 4 every time along the bottom. And so I plug in, I've got 1 over, and then 1 over 1/5 plus n minus 1 times 4. So 1 over 1/5 is, of course, 5, plus 4n minus 4, and simplify. So my general term would be 1 over 1 plus 4n. Okay, so you can check it. This is position 1, so n equals 1, so 1 over 1 plus 4. This is position 2, so 1 over 1 plus 8, and so on and so forth, and check it. This is kind of like other algebra things. You can check it, so do. All right, now, the other kind of cool thing that we can do with these sequences is you can actually graph a sequence on your calculator. So what you need to do is you need to go to mode, and down on the line where you choose what kind of graph you're doing, you choose SEQ. That means we're graphing sequences. And then when you go to y equals, you'll have this rather odd looking y equals term here. It's u equals this time, u of n. And so let's try one. If we have a sequence where its general term, it looks like n squared equals n squared minus 1, and we want to look at what the different values are, then we can plug that in and we use our n minimum. We're going to start with the first term, so we put 1 for that, and then we plug in our equation for the general term, and that n is just the x button there next to your alpha, n squared minus 1, and then our u in min, which means what is the first term. Our first term we're going to say is 0. Now we want to look at this, so we need to graph it in a window that's going to work. So we go to our window, and we're going to look at the first 10 terms. So we're going from 1 to 10, and we're going to go on integers. So we're going to start at 1, and we're going to step up every 1. And then for our x and y, we're going to go from -1 to 15 for our x and -10 to 100 for our y. If you list out the sequence, you'll see that why we need to do that. So then you hit graph, and you see the terms of the sequence are all listed there. And so you can see that n equals 1, you've got x is 1 and y is 0. That's our first term is 0. Our next term, the y values are our terms, and our x values are the place that they are. And you can arrow along here and see that our 7th term would be 48, and so on and so forth. So that's just kind of a cool trick to be able to graphically see what your terms of the sequence are. Make sure you understand how to get these explicit formulas and the 1 arithmetic, geometric, Fibonacci, factorial, and harmonic especially. And you can look at how to do it on the calculator as well.